The Swift Current Creek Watershed Stewards are a non-profit organization located in southwestern Saskatchewan with the goals of educating water users, monitoring water quality, and developing individual responsibility for water stewardship in the Swift Current Creek Basin.
This small watershed encompasses 5,592 square kilometers of land, and the creek is formed from 3 spring-fed tributary creeks originating in the Cypress Hills. The watershed ends where the Swift Current Creek joins the South Saskatchewan River just east of Saskatchewan Landing Provincial Park. In 2009, the stewards completed a source water protection plan in partnership with the Water Security Agency of the Government of Saskatchewan. One of the key actions identified in our plan is to address invasive species in the watershed with the intent to apply control measures and ultimately reduce the populations of invasive plants and animals. As we started to assess our watershed, we noticed field bindweed, Convolvulus arvensis, occupying large areas of the stream bank of the Swift Current Creek within the city of Swift Current. This is a noxious weed, meaning it is the same category as weeds such as downy brome and leafy spurge. Landowners are legally obligated to destroy or contain this invasive plant. There are legal restrictions on applying herbicides along the banks of a waterway because of the risk to water quality and aquatic habitat. In addition, the Swift Current Creek is deeply incised within city limits, and portions of the bank are highly erosive. Completely eliminating a plant occupying such a large portion of the bank could contribute to further bank instability. Learning a little bit more about the plant helped us to understand the problem it poses to the watershed and how it became so pervasive in the first place. Field bindweed has a taproot which can extend 6.5 meters deep into the soil, enabling it to access water that more shallow-rooted species cannot. Bindweed also spreads aggressively by underground rhizomes, and these rhizomes can grow 2.5 meters long. A single plant can quickly spread and form an extensive thicket. Once established, this perennial creeping vine will regrow early in the spring every year, outcompeting other seedlings trying to establish. Each plant produces up to 300 seeds every year, and they remain viable for up to 20 years in the soil. So even if the entire plant is removed from a site, new plants will start readily from the seed bank. The seeds also travel in water, posing a serious risk of contamination to downstream sites. We knew that it would be nearly impossible to completely eradicate the field bindweed with or without the use of herbicides. Still, we wanted to somehow address this issue. The opportunity arose with Go Green Friday, held September 27th of 2013. This annual event in Swift Current is sponsored by Stark & Marsh, a local accounting firm, and the City of Swift Current. Volunteers from these organizations and many other businesses within the city come together every fall to work on a variety of projects intended to improve environmental stewardship within the community. We chose a 20 square meter section of infested bank close to Elmwood Park to work on. Our goal was to displace the undesirable vegetation of the field bindweed by establishing a riparian forest on site formed of hardy indigenous riparian vegetation.
Natural processes restoration, often called ecological restoration, is a technique that seeks to assist the recovery of an ecosystem that has been degraded, damaged, or destroyed. Natural processes restoration makes use of natural systems in the design of restoration projects, asking the questions, through what processes do ecosystems assemble themselves, and how can I recreate these processes to promote the assembly of a desired suite of species? Natural processes restoration uses succession as a model for how ecosystems assemble themselves. The theory of succession is that after a serious disturbance, a site is first colonized by pioneering species which are adapted to the limitations of a disturbed site. Over time, nutrients, organic matter, and moisture accumulate there, and the vegetation advances through what are called serial stages. As taller vegetation establishes, it offers shade and protection from the elements to more sensitive plants. Larger vegetation slows the wind down, and mulch from deadfall insulates the soil, protecting it from the heat and also from heavy frost. While the idea of a climax community has largely been dismissed from the study of ecology, natural processes restoration makes use of nutrients, organic matter, moisture, shade, and protection from the elements to promote desirable species. Natural processes restoration is especially relevant when dealing with invasive plants. Many invasive species are pioneers and will not continue to establish on a site once successional advancement takes place.
An important natural process for most loadic riparian systems is annual or semi-annual flooding. When floodwaters reach up to the top of banks and then spill out onto a floodplain, they release energy and at the same time deposit organic matter, nutrients, soils, and seeds sourced from eroded areas further upstream. This deposition is what builds up the sterile status of riparian areas, turning them into moisture and nutrient-rich zones supporting complex ecologies. This natural process is largely absent within the city of Swift Current, partly due to 3 upstream control structures that alter the pattern of flow in the creek, and partly due to urban infrastructure and hardscaping that alter hydrology within city limits. These historic factors have contributed to creek incision, which is a process by which a creek bed digs down vertically over time, establishing deep, steep banks, which become dry and unstable as the water table recedes. The Elmwood site is particularly incised, indicating that the banks must contain high energy flow during flood season. Since the spring floodwaters of the Swift Current Creek are confined to the channel most years, we knew we had no way of imitating this natural process, but we believed that we could work with succession as a model and advance the site towards supporting larger and more diverse riparian vegetation.
Thorough site investigation is an essential first step to a successful restoration project. Our investigation considered the landform, the fluvial geomorphology, and the vegetation of the Elmwood site. The landform is an abandoned alluvial terrace, with the sandy loam soil high in organic matter indicating good nutrient and moisture holding capacity. The slope is a moderate 2-to-1 rise over run, which is steep, but not so steep that vegetation can't establish. In addition, the slope is north-facing, adding additional shade and moisture retention to the site. Creeks follow a predictable meander pattern, where sediment is eroded from an outside meander, carried through a crossover, and then deposited on the next point bar. Adding vegetation to a creek bank is a form of biological armoring and needs to be approached carefully. Stabilizing a point bar can actually increase the erosive force on the opposite side, whereas outside meanders are highly erosive, making for a risky work location. The Elmwood site is on a crossover, which is the safest place to stabilize along a creek without facing unintended consequences downstream.
Of all the site investigation that took place before we started, taking stock of the existing plant community was perhaps most important. Other than the field bindweed, the site also contained large amounts of one other invasive species, smooth brome. This grass occupies large portions of the bank of the Swift Current Creek and is pervasive throughout the watershed. It is classified as invasive and, like many other invasive species, is undesirable along creek banks because the roots of this plant are too shallow to maintain creek bank stability.
Native plants on site included western snowberry, wild rose, and wild licorice. Plant ecologists have identified what kinds of communities are possible if moisture increases on a site occupied by these plants, and which higher cereal stage species these plants are likely to associate with. If moisture increases, sites occupied by western snowberry can shift towards green ash, chokecherry, and willow. Western snowberry associates with Manitoba maple, chokecherry, aspen, and dogwood. If moisture increases on a site occupied by wild rose, the species composition will likely shift towards willow. Wild rose will associate with the same species as western snowberry, with the addition of green ash. From this information, we were able to develop a list of species we could establish on the Elmwood site if we could only advance succession. Wild licorice doesn't form specific associations, but we were excited to see the plant on site, as it associates with nitrogen-fixing bacteria. Our research also revealed a few commonalities between these species. They all form extensive underground root systems, making them excellent slope stabilizers. This explained why they were on the site. Western snowberry and wild rose are also early to mid-cereal stage pioneers and can facilitate successional stagnation in the absence of some form of disturbance that opens up cereal space and alters site conditions. In other words, these plants establish themselves so densely that they prevent any other plants from growing because all available space is occupied.
We started on the Riparian Forest Project at Go Green Friday, held September 27th of 2013. We first removed most of the vegetation on site, chopped all of the field bindweed and smooth brome using a combination of weed whackers and handheld X-Acto knives in order to get close to the surface. We also removed most of the rose, snowberry, and wild licorice in order to open up sterile space and to prevent these species from having a negative priority effect on the desired riparian forest species.
We retained some patches of rose and snowberry and the sole Manitoba maple on site. These were desirable plants. These species already played a role in stabilizing the slope and also provided community structure. That is, they would slow down wind as it moved across the site and offer shelter to establishing seedlings. These characteristics of the existing vegetation went a long way to providing shade and protection from the elements, some of the key tools for advancing succession.
The next step was to seed half of our native grass seed. The goal of seeding was to provide an alternative to the smooth brome at the top of the seed bed. Participants rubbed the seeds into the soil to create good seed-to-soil contact. As we removed the vegetation, we could see that the soil erosion issue was greater than originally anticipated, inspiring us to use a soil bioengineering technique called a wattle fence. A wattle fence is laid perpendicular to a slope and made out of plant materials. As soil moves down the slope, it is caught along the fence and stabilizes there, becoming a platform for new plants to germinate in. Any stems from the vegetation greater than 2.5 centimeters in diameter were cut into 20 centimeter segments. We inserted these segments into the soil at regular intervals along 4 lines running perpendicular to the slope to create the supports of the wattle fence. The stems were stripped before they were inserted to stimulate axillary and adventitious buds and encourage the segments to bud and develop roots. Our hope was that these segments would develop into new plants in the spring. The timing for this treatment was ideal as sugars are stored in roots and stems during the fall in preparation for winter. The smaller stems were gathered into long bundles in order to create the wattle fence retention wall. These bundles were placed along the slope, anchored by the wattle fence supports and by rooted stems as well. In natural processes restoration, waste materials are viewed as valuable resources, so the team really had to resist the urge to clean up.
The remaining vegetation was spread all over the site to create a thick mulch. This mulch was placed to imitate the facilitation that takes place in natural succession, whereby pioneer species assist later cereal stages to develop. In this case, by providing a source of organic matter and nutrition and insulating the soil from extreme temperature fluctuations. The mulch was also there to suppress regrowth of the field bindweed.
We then installed the coconut matting, a standard material used for slope stabilization. The matting was placed both to stabilize the slope and to further suppress the regrowth of the field bindweed. The project was left over the winter of 2013-2014 and revisited in the spring of 2014 to see how it had fared over the winter and during the spring flooding.
When the spring runoff happened this year, we just noticed that this snowberry and rose, there's 2 species kind of growing together here, had caught quite a large chunk of debris that was in the creek. So this was all deposited. It came from somewhere quite a bit farther upstream. And the other thing that we noticed this spring is that there was actually a lot of sediment deposited on site. So there's some new soil that's come with the creek that's been left on the banks. And kind of the point of this is that it just brings home the message that we try to promote as watershed stewards about the importance of proper riparian vegetation. Because this higher status vegetation, something that's a little bit taller, has the ability to catch that debris and to catch that soil and keep it on site, and actually builds the banks of the Swift Current Creek. So it's just very poignant as to why grass doesn't always work for creek bank maintenance, and that larger riparian vegetation is so important.
Digging down through the fresh sediment and coconut matting, we discovered that the mulch placed in 2013 was already degrading into a rich soil organic matter. Growth was not well established by May 30th as a result of late spring, but we could already determine some significant changes in species composition on site. Smooth brome was establishing in abundance, making a much greater contribution to species composition than it ever had before. A new species, common horsetail, was also emerging from the sediment. Western snowberry and wild rose returned to the site, with the snowberry becoming far more abundant than the rose. In the area where we applied the coconut mulch, the field bindweed was almost fully suppressed, proving the effectiveness of this treatment. However, we noticed the invasive plant establishing strongly all along the edge of the treatment area. With these notes taken, it was now time to start planting our riparian species. We organized the riparian species along a moisture gradient, with the moisture-loving plants such as dogwood and Manitoba maple near the base of the slope, and those which were drought-tolerant such as chokecherry and hawthorn placed towards the top of the slope.
Manitoba maple forest going here. Well, I figure it's better than field vine.
The site was again mulched heavily with a variety of organic waste materials.
We put down 3 layers. We put down some wood chips. After the wood chips, we put on quite a large layer of leaves, and that's what we did this morning. And they're spraying the leaves with creek water right now to just settle them and make sure they're not going to blow away, and also to provide some nice moisture and humidity on top of the trees that we just planted. And then on top of that, we've placed logs, like dead logs from aspen and ash and a few other trees that are in the city that were just part of the disposal. You can just kind of see with this type of a method for ecological restoration, it's been placed so that it's providing a little bit of a microsite to this plant. And in the northern hemisphere, the hottest sun comes from the south because it's always a little bit towards the south. So the way that this is placed, there's actually going to be just a tiny little bit of shade during the heat of the day from about 2, 3, 4 o'clock p.m. That is going to be shading right here where the roots are the most sensitive. So it's kind of just the placement of these things to provide some protection. And then in addition, it's going to be moisture under this log. That moisture is not going to leave the site, and because it's deadfall and dead rotting material, it's a little home for a lot of microbes and bugs, funguses, the type of soil ecology that we'd like to get cycling on site that's actually going to support and feed the rest of this system.
We left the site for the majority of the growing season, returning to it on September 19th of 2014 for another Go Green Friday.
It was amazing to see the diversity of species establishing on the site after only 4 short months.
Out of the saplings we installed, the Manitoba maple, the red osier dogwood, the hawthorn, and the chokecherry were establishing well. We could no longer find the green ash and aspen through the dense undergrowth. We were astonished to see that Manitoba maple and Siberian elm must have been in the seedbed, and several seedlings had started over the growing season as well. We were also excited to see some fungi growing in the understory, evidence of the improved moisture conditions and altered microbial community on site. While the bindweed remained suppressed, new vines were actually twining through the holes made in the coconut mesh in the spring in order to install the saplings. The Go Green Friday volunteers helped us to cut down and mulch the unwanted vegetation, which was mostly smooth brome. We layered wood chips, leaves, and woody debris one last time before putting the project to rest for another year. The greatest benefit to the stewards of this project was its ability to educate citizens on the importance of riparian areas through their direct involvement in establishing the riparian forest. At the same time, we were able to suppress the invasive species, stabilize the bank, and promote biodiversity in an urban setting. The stewards would like to offer a sincere thank you to the incredible partners who made this project possible: Stark & Marsh Accounting Firm, the City of Swift Current, and other businesses who participated in Go Green Friday.